Chapter 5 with discrete probability distributions is really where we started relying heavily on the pre-built-in functions in the calculator. Discrete random variables, remember, were usually tables presented where we have an x value and then a probability associated with that x value. So what's the probability that any married couple will have 0 or 1 or 2 kids, and then we have a probability associated with that, usually developed empirically. So you go out and sample a bunch of people, married couples, and see how many kids they have, and then you get probabilities like these guys, which are just made up. But that would be a probability distribution, and discrete because you count the number of children that someone has. From discrete random variables, we ask you to find the mean of the discrete random variable x or the standard deviation of that variable. The formulas for that, for doing it by hand, are on the formula sheet, which will be provided with the exam, but it was also handy to calculate these in the calculator. So in order to do that, the calculator needed both inputs, a list 1 for the x values and list 2 for the probabilities or the frequencies of those x values. Then hopefully you remember mean and standard deviation come out from one variable statistics. However, now instead of just one list like we used to have, there are 2 lists. So the screen that we'd like to use for that looks like this. You use the one variable statistics menu where you have a list for list 1, that's the x values, and then the probabilities list for list 2. No big deal, just like that. And then press enter and out will spit it. So turns out I pulled up my little calculator here and I have some lists in there. So in stat edit, remember right in there, you have some values. The x values I picked were 4, 5, 6, 7. Then we have these probabilities in list 2. Then quit from there, go back to stat and calculate one variable statistics with list 1 and list 2 as the frequency list. And out will come the mean for that distribution, x bar, and the standard deviation for that distribution, 1.08. So pretty fast in the calculator. The by hand formulas work fine too. If your calculator doesn't have this menu option like this, you would just put it in this way: 1 var stats, list 1, comma, list 2, and then press enter. The list options are second and the number. So second and 1 will call up list 1, and then a comma button here, and second and 2 will call up list 2. So you do that in the one variable stats operation to get those values back. That tells you we can expect that the average American couple has 1.5 children. That's where those answers come from the mean. Now the binomial, I think, is probably the trickiest thing for students because they don't have a flag. They'll just be these problems that ask you for a probability. And the thing that you want to look for are a fixed number of samples or fixed number of repetitions that have a binomial outcome. So remember, binomial means that there are 2 options. You crash your car, you don't crash your car, you have a child or you don't have a child, you pass the test or you don't pass the test. So you only have 2 possibilities. There are fixed number of times involved. We call that the sample size, or the number of times that the thing was repeated, and then there's a probability of success. Involved, and there's an x value, which is the desired outcomes that we're interested in. So let's say desired number of times. So the fixed number, the number of times you run the experiment, is n, the probability of successes is p, and the desired number of times that this thing has a success is x. Those are the important variables in the binomial distribution problems. To do this, there were 2 options we covered to find the probabilities: a super complicated formula, which is on the formula sheet and looks kind of ugly, the probability, the binomial random variable x, n choose r, p to the r, q to the n minus r, but it's just kind of freaky, right? And it was hard to get right all the time. So we didn't really use that guy. We either used the calculator or the table. Remember, if you want the binomial table, you have to bring your own. and the table was just find the sample size you wanted on the left column, then there would be x values here, and find the probability of success along the header, and the intersection of all those guys where you wanted was where you'd find that probability you wanted. So if you want the probability that x is 2 from a sample size of 10, you'd find that intersection, and whatever number reads right there, that's the probability that x equals 2. The calculator functions are a little more exact, and some people like that method, so I screenshot my calculator here for that as well. I'll pull it over. In the distribution menu, right, because these are probability distributions, you want to choose among the binomial PDF or the binomial CDF. And I get a lot of questions about when to use which one. The PDF is what to use when you have an exact value, the probability that x is exactly 2, and the C in CDF stands for cumulative. That's what happens when we add up probabilities, so this is what we do for the probability of less than or equal to some number. If you want less than or equal to from the table, then you would just add up all these probabilities from 0, 1, and 2. That would be less than or equal to 2. Or the calculator can add them up for you with the cumulative distribution function. The inputs there were these guys, n, p, x. So let's look at an example. It should be somewhere around here. So according to insurance records, a car with a certain protection system will be recovered 86% of the time. Find the probability that 4 of 10 are recovered. So you see it says probability. It doesn't have any kind of flag like it's a normal probability distribution or any of the probability rules, just probability. The outcome is that they are recovered. So the car either comes back or does not come back. That's a binomial. That's the sneaky part. You have to be able to read the problem and say, okay, I see that it's binomial. We had 10 cars, that's a sample size. The probability that any one is recovered is 86% or 0.86, and I'm interested in the probability that exactly 4 are recovered. Since it's exactly 4 of 10, that would be the binomial PDF, probability distribution function, sample size 10, probability of success 0.86, and the number that we would like to get back are 4. That will give you the probability. The next question, 44, also binomial. An adult was never in a museum is 15%, so that's a fixed probability. In a random survey of 10, so again, sample size is 10, what's the probability that 2 or fewer were never in a museum? 2 or fewer. So x can be less than or equal to 2. Now you either go in the museum or you don't, right? So if you've been in it, you've been in it. If you haven't been in it. That also is binomial. The fixed number of trials, a repetitive probability, and a desired outcome. So this guy is the binomial CDF, cumulative distribution function, all the way up to and including 2. Sample size 10, probability of success 0.15, up to 2. That will spit out the probability there. So that's one main difference between the PDF and the CDF. Let's go back to our list. And the normal probability distribution was next. These guys are nice because they usually have the big flag. It'll say such and such is a normally distributed variable with mean, mu, and sigma, standard deviation, whatever is stated. So as soon as you read that normally distributed flag, then you know you're in one of these 3 outcomes. And the first 2 are pretty easy. There's 2 things we can ask you, either to find a probability or to find a value. Find the probability means like I'm going to give you a value, you tell me the likelihood of that value or less, or that value or more, or that value and in between. Or you can find the value. So I want to know the cutoff value for 15% or something. You find the value. These are distributions, so they're still in the distribution menu, just like the binomial. We have the PDF and the CDF and then inverse normal. one thing I hope you noticed this semester was that we never ever use the PDF. That's the probability distribution function, but normal variables are continuous. It doesn't make sense to talk about the probability of being exactly anything with a continuous variable. What we use instead is the normal CDF when we want to find probability, the normal cumulative distribution function, and the inverse normal if we would like to find the value of the random variable. So if the problem says find the probability, use the CDF. If it says find the value for some given probability, use the inverse normal. These are the inputs in case you've forgotten them. The CDF needs a minimum value. That's where you start caring about the probability. Then a max, where you stop caring, a mean, and a standard deviation. And the inverse normal takes the area to the left of the cutoff, the mean, and the standard deviation. I always encourage students to draw curves here to help them understand what's happening. These are normal distribution curves. They're easy to sketch. Yours will be funky because you don't draw them 1,000 times a year like I do, but it doesn't matter. Just get the picture out there and then ask yourself like what you're doing. Like, are you starting here and then going forward? That helps find your min and your max. Or did you need to find a place where 98% of people are going to be able to fit through that door height? What's the door height? Or what's the probability here? That helps you understand your question and also where to put the values in the function. Then we had this sneaky little guy in this chapter on sampling distributions. It was actually chapter 8.1, but we snuck him in here because it said that when you were talking about the distribution of means, not just an x value, but an x bar, an average of some values, these guys are always approximately normal. I know that the software has you go through a whole lot of different requirements, and this is met and that is met or whatever, but thanks to the central limit theorem, sample means are always approximately normal. So when you're trying to talk about the probability that a sample mean is whatever, less than a value, greater than a value, between some value. As soon as you see this statement about probability, you know you need to use the normal CDF. With whatever your minimum value, maximum value, and mean are. And then because you're doing it on a sample mean, or it might say average, the key point is there you'll have a sample size in this problem that you didn't have in similar problems. Then the standard deviation is adjusted. You must take the regular standard deviation and divide it by the square root of the sample size. And that has to do with the fact that the distribution of the sampling means is less spread out. I'm sure you covered that in the theory, but the fact is that you have to make this adjustment. Now in the review, the final exam review, this is like number 54 and 55, I think, or somewhere around there in the review. So if you're having a hard time getting that right, make sure that you make this adjustment and make a flag to yourself. If the problem says probability of a mean, if there's a sample size, to adjust the standard deviation. Okay, so that covers it for Module 2. All these guys were finding probability with discrete, probability for normal, and then regular probability, right, just basic probability. So in Module 3, we start actually making inference on things. We made confidence intervals, hypothesis tests, and then regression to make predictions. So these guys all happen in the test menu, well, at least the first two. So I've pulled them up for you. If you're making a confidence interval, make sure to choose calculator functions that say the word interval in them, or at least int if interval won't fit. Then your decision is at least narrowed down, right? So then what you have to decide is, first, are you estimating the mean or are you estimating a proportion? What are you constructing a confidence interval on? The question will say, construct a confidence interval for the mean or for the proportion. If it says mean, then you'll use the t interval. If it says proportion, you'll use a z interval. However, the proportion has different inputs, so it has a different z interval. See those guys, A and B? Because the regular z interval, that guy's for means. This guy's for means. These guys are for proportions. They say proportion in them, so make sure you get the proportion one. Or if we're estimating the difference, that means there are two samples or two proportions. The same thing applies. Two proportions z for proportions, two samples for means would be two samples for t. Now this stuff was in chapter 11, but the concepts are the same as we did there, so I just put all the confidence intervals together. Hypothesis testing is very similar. We have the same question. Are we testing a mean or a proportion? If it's a mean, we'll use the t-test. If it's a proportion, we need a z-test. However, there are proportions, right? So we need to make sure we pick the one that says proportion. The only reason that there's a difference here is so that it asks you for the correct input. If it's a proportion, then you have an x value and no standard deviation. For the t-test or the z-test, they'll ask for standard deviations and means. Difference, again, that's what happens when you have two sample z or two proportion z. Not two sample z, two sample t down there. The final exam answer sheet does ask you to state these 4 parts of the hypothesis test. First, what is a null and alternative hypothesis? So you'll need to write the null hypothesis, the mean is equal to 49. The alternative hypothesis, the mean is less than 49. Find the test statistic, t equals whatever that value is. Spit out the p-value, just like you did in the homework, and then make a decision, reject or fail to reject, based on that p-value. The review answers are formatted similarly, so you can make sure that you do it, but just make sure that you are practice writing out these 4 parts and you can be clear. The most commonly missed stuff are people forget to include the parameter at all. They just think that they can put in what they have in the calculator, which is kind of just this part, but that's not a full statement. So make sure you include what the thing that you're testing in your hypothesis test. And lastly, for the very end, we had chapter 4, cycle back and get the regression. Hopefully you figured out that that's pretty quick and easy in your calculator as well. The different thing about regression is that it's what we call bivariate data. That means we observe 2 values on each individual, so there will be 2 measurements. Like, let's say we take a person and we want to get their weight and their height. That's 2 measurements on every one individual. So you have some weight value and some height value, weight value, height value, right? The linear correlation coefficient R measures the strength of the relationship between there. The least squared regression line y hat equals ax plus b. It tells you what that line looks like, and then we can use the line to make predictions. We didn't have to cover coefficient of determination this time, but to make predictions, we just plug an x value into the least squared regression line. The least squared regression line might be given. Our job is just to use it to make a prediction. You just plug it right in. This is kind of basic. I like to use it at the end of the chapter. It's different because of this bivariate thing, but it's not too complicated. Hopefully you figured out how to run it in the calculator. Of course, weight would be list 1, height would be list 2. Each variable gets its own list. And then you can run linear regression right here, ax plus b, which will spit out the linear correlation coefficient and the equation of regression. Y hat would be ax plus b, and the calculator will spit out a and b. So in case it's not working for you quite how you wanted it to, you need to make sure to turn on stat diagnostic. You only have to do this one time until you reset your calculator right before the final, and then you'll have to do it again, and I'll remind you. Go in mode and scroll down until you see stat diagnostics. It's off right now. So because it's off, you'll see if I run the regression. All I get is the regression line, but no correlation coefficient R. So that makes me sad because I need that R to finish my homework, and it's a lot of work to calculate it by hand. So like I said, back in mode, scroll down to stat diagnostic, and turn it on. Once it's on, it will spit back R. If you don't have it in mode, then you have to search for it in the catalog, like with the older operating systems on the calculator. That's no big deal either. Just takes a couple more button clicks. The catalog is second and 0, and that's a list of all the functions the calculator can run. So now your job is to scroll down until you find diagnostic on. It looks like that, diagnostic on, press enter probably twice. Call the function and then run it. Okay, so you found diagnostic off, then diagnostic on, press enter, press it again to run it. Now that diagnostic is on. Back to stat and calc number 4, or you can use number 8 if you like, it just changes the values around. The X list is L1, the Y list L2. Nothing for frequency, nothing for to store the regression equation. And then calculate. And now you'll see we have the R value. That's the strength of the relationship between the two values. That's the linear correlation coefficient. You want that guy. This is not a very strong relationship. These random variables that I happen to have in my calculator appear not to be linearly related. That's okay. Linear correlation coefficient R, and then A, B, and Y together make the equation of the least squared regression line. So common mistake on the final is just to write these numbers down, not the equation of the line. So this line would be negative 0.0155x plus the B value, 0.3351. That's an equation of a line, right? Y equals mx plus b. Sometimes I just get random number lists. Sometimes people will put them in the wrong order. Y hat is 0.3351x minus 0.0155. That's a completely different line. So notice right here, it tells you the order. A is the number that got multiplied by x, and B is the spare number that did not get multiplied by x. That's not this. That's a different line. It means different things. So make sure that you put them in the right place. And we're not trying to be tricky on the calculator. It'll tell you what you picked. You just have to follow the form. Even if the form for the formula sheet might say y equals a plus bx. B is the number by x, a is the free variable. Don't just change it if you ran this formula. Use the formula for the function you ran in the calculator. That's just another place where students get confused.